Hello and welcome back to Jono's lab. I thought in today's video I would explain how we could establish the caffeine content of a random tea or coffee or energy drink that you could buy in the store. And so for most of the video we're going to pretend that we can't just read the label. And I have found, like, especially some kombuchas and iced teas and things, they won't specify how much caffeine is in there. A lot of energy drinks do. So let me show you how I did this. The basic idea is that we're going to be using these things called TLC plates, TLC standing for Thin Layer Chromatography. And these are going to let us separate out the different compounds within the drink so that we can focus on just the caffeine. And at the end of this process, we're going to end up with a really nice measurement of exactly the dose. So the idea is, you can see I've got my samples of different teas and coffees here. And then also I used some pure caffeine, which you can buy on Amazon. I think people use it cosmetically, to make up 1,000 milligrams per liter, 500, 250, 100, 50, 25, some different standards of different concentrations. And so then once we spotted on exactly the same amount on each, I used a pipette to spot on 7 microliters, but you could also use a thin capillary tube to get a consistent spot size. That would also work. Then we place these so that just the very bottom end of the plate is in some solvent. In this case, I used ethyl acetate. You could try acetone, but it tends to give a smearier result. So the idea is that the solvent is then going to move up the plate over time, and it's going to carry along some of the chemicals with it, and they're going to move different amounts depending on how much they stick and interact with the silica coating on the plates. And then we can illuminate those plates with 250 nanometer UV from I've got a little germicidal UV lamp, being careful to wear eye protection and not get it shining on ourselves too strongly. And you can see here's the different strong, weaker caffeine standards that I made up. And then here is the, melting forest energy drink dotted over there. And you can see it's quenching the ultraviolet, and so it's showing up as a dark smudge on the TLC plates. Here's another run I did with even weaker caffeine concentrations, and then some very weak teas that I brewed, as well as decaf versus regular coffee. And if you shine a 360 nanometer UV instead, you can see some other cool compounds that are in the coffee. And this one is yerba mate. Also got some fluorescent, I guess, polyphenols or something like that. And these ones very sticky and didn't move at all. These ones carried along by the TLC process. Okay, so we've got a nice picture, and you can kind of visually say, oh, this looks about the same as this known concentration of caffeine. But we can do one better than that. So here I'm in it's called Solvit. It's like a Jupyter notebook style dialogue, and I used a lot of AI assistance for like the plotting and things, but also just wrote a lot of the code piece by piece. And so the idea here, let's do the energy drink example. We've got some known concentrations, and then we've got our unknown splodge. And so I just specify where we're going to examine a sort of rectangle around those smudges, and then we can extract the average intensity across the x-axis, and then we can plot along the y-axis, and you can see we get this kind of like obvious spike with larger spikes, larger deltas for the darker smudges. And so then we can smooth that out and fit a power law, and end up with a pretty nice relationship between the concentration of caffeine in the known samples and the intensity, the normalized intensity or delta, how much darker the smudge is versus the surrounding area. And then we can take our unknown sample, we can look at its intensity and use that to back calculate a concentration. So I'll share this code below. So one thing that I thought was fun was quickly just whipping up something that says, what if we are coloring these measurements somehow by choosing exactly how wide and how long these boxes are. Let's vary that up a bunch of times. And so then what we can do is, let me find a good example here. Yeah, we can run this hundreds of times with different variants. So let me use 500 pixel long versus 400 pixel long boxes, or change the width, change different settings about this analysis, and you get a kind of a distribution of estimates. So you can see for the melting forest one here, the mean estimate is 144 plus or minus 20. So 144 is the mean of all of our ones when we varied up those widths and heights. But you can see there's a bit of a spread. So it's anywhere between, say, 120 to 160 seems to capture a lot of the most likely spot. And if we look back at our picture of our can, it is exactly 150 milligrams of natural caffeine included in with all the other weird bits and bobs. So anyway, our analysis is pretty spot on. You can see here's some nice error bars on that version of the plot from earlier. And so, yeah, this seems to work well for tea and coffee. And the nice thing is, because you're doing this TLC process rather than just a main, like, looking at the absorbance of UV light of the full liquid, you're not getting confused by all of the other compounds. If you've got all these other smudges and things, these are different compounds that are kind of moved out of the way by the TLC process, and then also made a nice and easy, obvious visual that your phone camera can capture for how much caffeine is in the drink. So yeah, I hope you found that interesting. Let me know if you try this. I'll definitely be keeping this in mind if I'm ever curious about some drink. I'm not going to finish this slightly synthetic tasting mushroom energy drink, but it was fun to have a test with a known concentration that I could compare. And I am going to use this testing out my various teas and so on. Anyway, thanks for watching. I hope you found that interesting. We'll see you in the next one.